Hello everyone, this is Mr. 13 Things, Silence Did Good, or Papa, if you care. Coming at you today and trying to encapsulate in a very short series of videos what you learn when you learn to run your calculator. And it is not necessarily just how to avoid math or how to run a calculator. And I'm going to try to crystallize this for my wonderful kids and anyone else who wants to hear about it. I'm going to use the TI83. I could use a TI84 Plus for a number of reasons. One, it is a good, reasonable calculator. It has a programming language on it which isn't great, so you'll quickly learn to program in something else like Python or JavaScript, but it is doable, and it is allowed on the ACT exams. It has a good matrix calculator, and it has a reasonable graphics capability, though it does not have the crazy fun stuff that you can do off on your phone and waste infinite amounts of times. The first and most important thing to learn when you learn to run a calculator, and you're seeing this over here, and I'm going to try to go ahead and turn it on. The first thing you do is ask it a series of questions that you know the answer to. Hopefully those go off to the world where you have a differentiation between talking in angular measurement to between degrees based on an archaic method and radians being the only real thing. So the first thing you're going to learn, hopefully very early, is the tangent of 45 degrees is 1. So when you plug in something like that and you do not get the right answer, that's one thing you know something isn't set right. You ask a machine, after checking the batteries of course, some questions you know the answer to. The next question you might ask is e to the I pi, because that's just cool. This also gets you to the point of remembering that a lot of parentheses are better than few. E to the second I second pi. And you should know that equals, albeit that's almost 0. So that's a problem. But knowing that that should be 0, e to the I pi equals -1. And that is not the case. E to the I pi equals -1. Now, all of a sudden, you can look at this and realize, wait a second, e to the I pi is -1, and that's what that number is. There's a plus there, right? So that's and this is coming in a weird way. So that might throw you, so you might not want to use that one. But the tangent of 45 is something you should be learning very quickly. But once you've had imaginary numbers, and you should have them earlier than later, you should realize that you ask this some questions you know the answer to. So that's how it should be taught. What most folk would let you know, and I'm going to finally do this, the last question is going to be 1 times pi, and you see that it's giving you a lot of decimal places. What some will say to you as you learn a calculator is, don't change the settings. In life, someone will always have changed the settings on you, and so the other way to go about doing this is to actually always go and check your mode. It's the same thing in many ways as asking the calculator a question you know the answer to. And in this case, you have a mode: normal, scientific, or engineering; float, or number of decimal places; radians or degrees is the key important one. Whether you're going to deal with equations in a regular function, in a parametric way, in a polar system, or in a sequential system; how you're dealing with some graphs, how you're running things, how you're dealing with imaginary numbers, and then how you're dealing with the screen. The key one, of course, being the radian versus degree. So let's go ahead, and I'm going to click down to here. Clicking down, and I'm going to enter degree, and I'm going to now hit second quit. and once again say the tangent of 45, and it gives me the answer 1. I will once again, and the reality is you can go back, I think. You're not in this one. Usually you can go back. I'm going backwards here. E to the I pi. I'm going that by doing second enter. That's useful. It's going back in the stack to what you've pushed in the past. So e to the I pi in this case. Interesting. E is -1. It gives you the same answer. Boy, that's a really interesting one because you are still measuring in radians, but I guess in reality it doesn't make any difference. That's what we get here anyway. So I'm thinking through this, and that's not a good question to ask because it's going to give you the right answer no matter how your settings are set. You start delving in, even listening to me, into some of the wonderful things that occur when you get out of the archaic degree system. So the most important question, the only question I guess is to ask, is the tangent of 45, because it's going to be 1 if your calculator is set to degrees, and it's going to be 1.61 if it is set to radians. You want to know what system you're in. That's the single most important thing to do. The next thing that becomes important in the calculator is to make sure that you're dealing with, when you're dealing with lists, right, I'm going to clicking here on the window here, or not, I have to turn it back on, that you have lists defined, right? And when you set up plots, second test plot, that you have the plots for the stat plots off, unless you are using them. And you'll see later why, that if you have a list 1 and not a list 2, you're going to get this ambiguous error. So I will demonstrate that in the second video. But you want to make sure your stat plots are off. And finally, a real important thing when you get going on this is that when you're setting up your window, that you have the scales set so you're actually getting a non-skewed plot. That's very typically done by setting this up so the X is wider than the Y, and we'll show you what that means later, so that when you do graph a picture, Y equals X, and then graph it, that you get a 45-degree line. And you see your eye is showing you that this is not a 45-degree line because your aspect ratio on a screen is off. And if we're going to train ourselves to live in a real world and approximate it with math, we do not want to untrain our eye. The other thing you'll see would be to draw a circle and make sure it looks like a circle. A circle can be a little bit more difficult, one of the downsides of this calculator, because you just can't put x squared plus y squared equals 1 to draft a unit circle here. So realizing that you want to go ahead and make sure that you have your scale set. I'm going to try this. I'm guessing at it. It's a number you should know. It's basically an aspect ratio thing. So I'm going to go here 1 to 16, and x max is 16. And then the same for y, and I'm once again going to graph. And now you see that's a 45-degree line to your eye, and these ticks are, or thereabouts, this is a 45-degree line. So knowing that that window is set, and actually that's also can be done by Windows Zoom, I think. And you can do Zoom Square. And that actually gives you, and then if you go back to window here, it actually gives you some of that, more or less, the ratio of one to the other. All right, so what you do when you pick up your calculator every time is you do that. I know it might seem odd or problematic. The last thing I'll let you know is realize that this calculator can solve lots of things, but you never put them in a store like a normal calculator you've been trained on. You put them in letters that make sense. And so I'm going to put 25, I'm going to hit second quit. I'm going to put 25, store it into the letter A. And I'm going to put 30, store it into the letter B. or the variable b, and then if I just do a plus b, I have a value there. There is a huge and important sense of what's going on in terms of storing things as you go along with that. So learning to put variables into single letters is not a great trait to transfer over to programs, but knowing that maybe A stands for apples and B stands for bananas, and then A plus B is the number of fruit, that's the kind of training you want to do with these letters. And also write down on a side sheet of paper, and that's why I have this up over here. Hopefully, though, A is apples, B is bananas. So these are variable declarations. Variable declarations. So I'm going to end it there. Remember, 1, ask it a question, you know the answer. Ask a question that you know the answer. 2, and the same thing, check the mode. 3, graph a line. Graph a shape you know the answer to. Graph a shape you know so you don't untrain your eye. And this transfers then over to reading graphs and into life. Think about doing this with a chainsaw. And then you can understand when you're learning to run your calculator, you're learning to run machines, not just calculators. Thanks for listening.